Okay, so a girl is flying a kite. The length of string from her hand to the top of the kite is 60 meters. So 60 meters is which name? Adjacent, opposite, or hypotenuse? So hypotenuse. Okay, that's great. The string which is being held 1 meter above the ground makes an angle of elevation with 50 degrees to the horizontal. Okay, calculate the height of the kite above the ground correct to the nearest meter. So what we're going to do here is we need the height of the kite. So technically, our aim of the experiment, aim of the question is to go from here all the way down to there. Okay, but by construction, if I just go straight across and intersect it there, what I can do is I can guarantee that that there is 1 meter. How do I know that? It says that her height is 1 meter, and if they're both on horizontal ground, it's going to maintain itself as 1 meter. So realistically, the question is basically all about this length here. Okay, we just call that h, and whatever h is, we're going to add on 1. Actually, I won't call it h because h gets mixed up with hypotenuse. Maybe use a neutral letter, a letter that not a, not o, not h, k. Okay. Oh, she just let go. Now, what we have here, guys, is this. We're looking for k, but we have the hypotenuse of 60. What label would you give k? Opposite. Okay. So it's the opposite side. We could do in a second if you wanted, yeah. Just call the opposite, and that there is the hypotenuse. So can we use Pythagoras? Don't have all 3 sides, so Pythagoras is completely ruled out. Therefore, if Pythagoras is ruled out, you have SOHCAHTOA. Which one should I use? We'll go over with Daniel. Sine, cos, or tan for this one? Sine, okay. What did you choose, sine? Because it's a hypotenuse and opposite. So sine 50 equals k over 60. Move up to 60, and what do we get? Move up to 60. So 60 sine 50 equals k. What is k? K is 46 meters, is it? Okay, 46 meters. So 46 meters into the air. Now, what's that? Yeah. Oh, it's not the scale, right? Yeah, it's not the scale. '60 sin 50. Yeah, 45 rounded up to 46. Now, we have to add on the extra meter, don't we? So the answer is actually 47, because you have to add on the extra meter at the end. Now, lads, there's a device called a clinometer, okay? Clinometer measures angle. So as an example, how a clinometer works is like this. If I have it asks me how it might be measured, okay? So there's a device that you might have used in geography before. When you look up, it's like a binoculars. When you look up an object and center it on the screen, it tells you what angle you're looking up at. So here's how it works, okay? So internally, it has sort of a system like this, where it has a upside down. It has one of these. A protractor, and this protractor comes down here. And what I do is just turn it upside down. Okay? Now, when you're looking at something on level ground, so when you're looking at something going directly across, what happens is they hang a weight from the clinometer. Okay? Yeah, it's like a string with a weight. Okay? And what this does next is, if you want to look at an object in the distance, so let's say for example the kite. Okay? Right, and the kite is like this, and the kite sorry, I'll do a different color one. The kite is at this angle here. Is that alright? What you do to measure that angle is this. See the way that starts off at 90 degrees? It's currently straight down, which means it's at 90 degrees. What happens next is you actually turn it until it hits the angle up there, and you can see that it's actually at you can see that that's at 116 now. So it went from 90 and now it reads 116. What's the angular difference? 26. So the angle is 26 degrees is what you're measuring. That's how a clinometer works. So when you're up here and you're trying to measure that angle of 50 degrees, what in theory what you can do is this. You can just bring this. You have your clinometer. Now this is obviously scaled up to a massive extent. You have that going straight down. You have your pendulum weight going straight down. You have you're looking straight across, and then what you do is you rotate it until it hits up there, and you can see that it was 90 degrees. Now it's going to read 140. So it reads 140. Sorry, 140. It was 90. 140 take away 90. 50 degree angle upwards. That's yeah. No, as in you might have to explain the workings of a clinometer. Or they've given questions in the past where they use the clinometer and they actually ask you how to work the measurement. Okay, so a random clinometer question might be something like this. Okay, so what they might do is they might ask you like the reading on the clinometer. Oh. Okay, so the reading on the clinometer might be something like this. Took a while to get out of the way. So they might have it like straight down, and then they might go, okay, the clinometer is this way. What angle is it looking up at? What does it read there? Can anybody tell me? 130, which is how far away from 90? 40. So you're actually looking up at 40 degrees. If you're looking down at something, it'd be the other way around. So if I said this reading here, how far are you looking down? It was 90, now it's 50, so you're looking down at 40 degrees. That's the workings of a clinometer. Okay? Now, clinometer. Clonometer. Clinometer. Now, next one. When a person stands on level ground at a point 100 meters from the foot of a vertical cliff, the angle of elevation from off the top of the cliff is 40 degrees. So just remember something: the closer you get to a tall object, the further you have to look up. If you've ever seen a skyscraper in the distance, you can see the skyscraper, the top of the skyscraper, by barely even lifting your head whatsoever. If you're right underneath the skyscraper in front of the building, you have to tilt your head all the way back, and even then you might not be able to see the top of it. So what I'm trying to get at here is that the closer you are to an object, if I was in here, I'd have to look even higher. If I'm all the way back here, it's a small angle. Does that make sense? Okay. Now, so what it's asking me is calculate the height of the cliff. How many triangles do you see? How many triangles do you see? 3. The height of the cliff is in how many of those triangles? 2. The right one and the big one. And which one has the most information? The right one. So you start off with the right one. So you start off with 100 here, 40 here, and you're looking for the opposite side, or the height of the cliff. Any ideas how to do that? Can we use Pythagoras? Why? One side. What should I use then? And which choice of the three? Tan. Tan 40 is opposite over 100. So the opposite side is going to be what? And what is 100 tan 40? Okay, 84 meters, okay? So you now know that that's 84 meters. Now, 84, yeah? Goes that way, yeah? Now, so guys, what we have here is this 84 here Okay. Shh. Excuse me. Whereas, if the person moves to a different point on level ground, 244 meters away from the foot of the cliff, what will the measurement of the angle of elevation be then? We want to find this angle now. Okay, so I was to redesign this triangle, and sorry, well, very little elevation. There's always a slight elevation, but nothing. 244 on the bottom, and then it's 84, and we're looking for angle Y, we'll call it. So anybody wants to tell me how to get angle Y? Tan Y equals, and then after that, and what you get when you tan inverse it? Tan inverse 84 over 24? 19 degrees. Okay.